This question. First and foremost, if I have a current here, okay, now and the current passes through what 2 ohms, okay, and the same current travels and enters this particular 2 ohm, what comes to your mind? It means that the current that is passing through these 2 ohms is still the same current that is entering this particular 2 ohms. I remember I said when resistors are in series, they have the same amount of current. So it shows that these 2 ohms and these 2 ohms are both in series. Okay, so let's solve these two in series first. So the first series connection now, which is this and this, so the 2 ohms plus 2 ohms. Okay, 2 ohms plus 2 ohms to give us what? 4 ohms. Okay, so these two now, when we solve them in series, we're going to be having what? 2 ohms. Okay, now come back here. If a current passes through these 2 ohms and travels and enter this particular 2 ohm, say that what? This and this are also what? In series. Why? The same current is passing through this 2 ohm and this 2 ohm. So these two are also what? In series. So second series connection. 2 ohms plus these 2 ohms plus these 2 ohms. Okay, we'll be having what? 4 ohms. Okay, so we have solved this to get 4, we've solved this two to get 4. Now let us see another diagram of this, different version of this. If we check, these two now are in parallel, so we have to solve these two in parallel. Okay, so let's get the parallel connection. Now 1 over R equals 1 over 4 ohms plus 1 over what? 4 ohms. Okay, LCM of 4 and 4 is 4. Okay, so we're having 4 ohms here. And divide 4 by 4, that is 1. 1 times 1 is 1. Divide 4 by 4 is 1. 1 times 1 is 1. Now 1 plus 1 is 2 over 4 ohms. Okay, so we're having what? 2 over what? 4 ohms. All right. Now, if 1 over R equals 2 over 4 ohms, okay, we can cross multiply. Okay, so 2 times R is 2R equals 4 ohms. Now, divide both side by 2, both side by 2, 2 cancels 2. Now, R equals what? 2, so that is 2 ohms. Okay, so I have solved this 2 now to get what? 2 ohms, because these 4 ohms and these 4 ohms are both in parallel. And when you solve them in parallel, you're going to get what? 2 ohms. Okay, now these 2 ohms is now in series with this. Okay, so it's going to be third, let me manage here. Okay, third series connection. Third series connection. Okay, so that will become these 2 ohms and these 2 ohms. Sorry, 1 ohm, beg your pardon. 2 ohms plus 1 ohm. That gives us what? 3 ohms. Okay, so the total or the effective resistance in this particular what diagram is what? Is 3 ohms. Okay, now go back to what's the Ohm's law. V equals IR. Okay, our V there is what? Is this 12 volts? Okay, then we're looking for I times our R now is the total what? Resistance. So go side by 3, go side by 3, 3 cancels what? 3. Our answer at the end of the day, our current now is, put it down, our current equals 3, 3 here 1, 3 is 4, that is 4 ampere. So our current here is what? Is 4 ampere. All right, it's simple, straightforward. Okay, all right, now let us take a look at the second question. Look at this question. Okay, so you have a diagram like this, and then they said using the data on the diagram, okay, calculate the PD across the 20 ohm resistor. So how do we solve this kind of question? Now, we are given 2 ampere. All right, now it shows that this resistor and this particular resistor are not in series, they're in parallel. Do you know why? Because they gave us 2 amperes, which means that this 2 ampere is the current across these 5 ohms, but it is not the current across these 10 volts. Okay, so That means they are what? In parallel. But can I tell you something right now? Now, if I can get the potential difference here, okay, if I can get the potential difference here, now whatever value I get as my potential difference is still the same potential difference across these 10 ohms. Do you know why? Because when resistors are in parallel, they have the same potential difference, but their currents, are not the same. So in this case now, let me first of all get the potential difference, okay? Potential difference across this particular 5 ohm, that will still be the same potential difference across these 10 ohms. So let's start. So from here, from Ohm's law, V equals to what? IR. Okay, my I is 2, my R is 5. So 2 times 5 is 10. That's 10 volts. Okay, so 10 volts is the PD across 5 ohm. It is still the same PD across what? 10 ohm. So PD, that's potential difference across 5 ohm, is what? It's 10 volts, and the potential difference across 10 ohms is also what? 10 volts. Why? They are both in parallel. All right. Now, but the question says I should get the PD across these 20 what? Ohms. Now, since I have the PD across this 10 ohm as what? As 10 volts, can't I get the current? Of course, I can get the current. Now, let's get the current across this 10 ohm resistor. Let's see. V equals what? IR. Okay, so V across this 10 ohm is what? 10. Okay, we don't know the current, and then our resistor. We're looking for the value of the of the current across this 10 ohm resistor. Now that is 10. So both side by 10, both side by 10. 10 cancels 10. So I equals 1 ampere. So 1 ampere is the current across 10 ohm resistor. Okay. Of course, they gave us 2 ampere as a current across what? 5 ohm resistor. So what do we do? To get the total current now, let's try to get the total current. Total current. Total current across the circuits. Okay, so total current across the circuit will be the current across this across the 5 ohm resistor, which is 2 ampere, plus the current across this 10 ohm resistor, which is 1 ampere. So total current is what? 3 ampere. So 3 ampere is the total current across the circuits. Now, with this, it becomes easier for us to get the potential difference across this 20 ohm resistor. So let's look for it. V equals what? IR. Okay, so V equals I. Now, take note, this 3 ampere, like I said, is the total current. So that means the current that this particular battery supplies is what is 3 ampere. So 3 ampere is passing through what this 20 ohm resistor. So I'll be having I is 3, R is 20. Okay, so V equals what? 60 volts. So the potential difference across this 20 ohm resistor is 60 volts. All right, is that clear? Okay, so just go through the steps and then you arrive at the answer. Let us see another question. Let's look at this question. Okay, you have a diagram like this, and the question says we should calculate current in the 12 ohm resistor. So current in the 12 ohm resistor. What is the first step? Now, these two are in parallel. Okay, so let's first start by getting the effective resistance. So they are both in parallel. Then let's start. 1 over R equals 1 over R1 plus 1 over R2. And that's equal to 1 over. Now, our R1 is what? Is 12 ohm. And our R2 is what? Is 6 ohm. So I'm having 1 over what? 6 ohm. Okay. Now, 1 over R equals. Now, LCM of 12 and 6 is what? Is 12. Okay. So I'm having 12 ohm here. Let's divide 12 by 12 is 1. 1 times 1 is 1. 12 divided by 6 is 2. 2 times 1 is 2. So 1 plus 2 is 3 over 12 what? Ohms. Okay, so 3 over 12 ohms. Okay, now 1 over R equals 3 over 12 ohms. So we can cross multiply. 3R equals 12 ohms. Now both sides by 3, both sides by 3. 3 cancels 3. R equals 3 is what? Is 4. So we are having what? R equals what? 4 ohms. So 4 ohms is the total or the effective resistance in this particular circuits. All right. Now, the next thing is this: if I do not have, or if I wasn't given 1 ohm as my internal resistance, then I can conclude that this 12 volts is the potential difference across 12 and 6, because since they're in parallel, they have the same potential difference. Okay, but the challenge here is this: I have 1 ohm as the internal resistance. Okay, or internal resistance. Sorry, internal resistance. Now, what do I do in this case? It is better for me to get the PD across this 1 ohm, which is what the internal resistance. So let me go for the PD across this 1 ohm first. And when I get the PD across this, I can take it away from 12 to get the PD across 12 and 6 ohm. Okay, I can't just use this 12 for this 12 and 6. What I'm saying is that I can't use this 12 volts for this 12 ohms and 6 ohm. It's not going to work that way. Why? Because of the internal resistance that is included in the question. All right. So what I simply going to do here is that let me find the PD across this 1 ohm resistor. So V equals IR. Okay. Now, but if we look at this, we don't have the current. So it's going to be very difficult for us to get the PD across the internal resistance if we don't find the current. So let's get the current first. Okay. Now, let's leave this alone. Okay, let's get the current. V equals to what? Let's use this. I equals E over R plus this. Okay, we divide this. So my I, what is my I? My I is not given. So I equals my E here. My E is what is my 12 volts. Okay, so 12 over my R. Okay, my R is the external resistance, and that is what 4 plus my small r here is my internal resistance. So that is what 1. So I equals 12 over what 4 plus 1 is what is 5. So divide 12 by 5, that is 2.4. Okay, ampere. So 2.4 ampere is the total current that flows through this particular circuit. Now let's come back to this. Now let us get the PD, okay, across the internal resistance. So V equals what? IR. So what is my I? My I is my 2.4 as the total current times my R. What's my R? My R is what? Is 1. So 2.4 times 1 gives us 2.4 volts. Okay, 2.4 volts is the PD across the internal resistance. Now let's now get the PD across this external resistance. Okay, because the PD across this external resistance plus the PD across the internal resistance will give us what? 12. Okay, so PD across the external resistance. PD across the external resistance. Okay, will be given to us as this: big V equals 12 minus 2.4. Okay, this 12 minus 2.4. 2.4 is the PD across the internal resistance. Okay, so when we subtract, we'll be having 9.6 volts. Okay, 9.6 volts. So 9.6 volts is the PD across 12 and 6. Remember, they are in parallel, so they will have the same potential difference. So let's now get the let's now calculate the current in the 12 ohm resistor. So it's going to be V equals to what? IR. My V now is 9.6 equals I times R. R is what? 12. Now both sides by 12, both sides by 12. 12 cancels 12. So my I equals to what? 9.6 over 12, and I equals to what? 0.8 ampere. So 0.8 ampere is the current across the 12 ohm resistor. Okay, so if you have watched this video up to this time, okay, and you really like what you have seen so far, kindly press the subscription button and then like this video. Okay, so I'll be showing us more questions on physics, chemistry, mathematics. I'll be treating several topics on these three subjects. Okay, so until our next class, take care of yourself and bye-bye.